Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Today we're going to be looking at systems of equations with three variables, and this one's going to be done from an algebraic standpoint. I've turned my paper sideways because I like having room to work across the page and have extra space so that it just lines things up. I also happen to like using graph paper for this or some kind of grid paper so that I can organize things and make sure I keep everything nice and tidy as I go through. Our first system is going to utilize the variable a, b, and c, and I've just picked a, b, and c because that way it's different than your traditional x, y, so that you can get used to seeing other variables. So we got 5a plus 4b plus 3c equals negative 12. A plus 2b plus 3c equals 6. So right here what I notice is that I have three variables, a, b, and c, and they are all in standard form. The a column lines up, the b column lines up, the c column lines up, and then what they're equivalent to lines up, also known as a constant. And then moreover, I notice that my c's are positive 3 and a negative 3, which means that the top equation is an additive inverse to both the middle and the bottom equation. I like to have my one that has the same coefficient but a different sign be the middle equation. So I'm just going to go ahead and take that top equation and move it into the middle. I'm going to write that directly below. So we have 5a plus 4b plus 3c equals negative 12. And I'm trying to write a little bit smaller so I have more space to work across my page. Negative 6a plus 2b minus 3c equals 23. A plus 2b plus 3c equals 6. And I know that when we did systems of equations in two variables, I gave the options and showed both ways of substitution and elimination. I very rarely use substitution as my straight-on path with these unless I'm doing creative substitution. So I prefer the elimination method, which means that we use additive inverses. So if you notice right now, we have a positive 3c, a negative 3c, and a positive 3c. That's really going to be key to helping us solve this quickly and easily. So I'm going to kind of treat this like a bracket so that you know as you go through like a basketball tournament, teams get kicked out. And that's the same thing we're going to do here is we're going to target variables and kick them out. So because of the coefficient for c adding to 0, I'm going to go ahead and target c. But again, we have to have that bracket. So we have to have the top row and the middle row face off. 5a minus 6a is negative 1a. 4b plus 2b is positive 6b. Positive 3 and negative 3c equals 0, so they cancel out. So I don't need to write anything about c, hence the word eliminate. And 23 and negative 12 add to 11. Okay. Then we also have to do that middle row compared to the bottom row. So again, that bracket mentality coming in. We have three teams, as you want to say it, in the first round. We're going to go down to two teams in the second round. So negative 6a and positive a is negative 5a. Positive 2b and positive 2b makes positive 4b. Negative 3c and positive 3c happen to go ahead and cancel out. And 23 and 6 add together to make 29. So now that we targeted c in the first tournament, or first round, this next round we need to pick a different variable to target. I could try to get 6 and 4 to the same number, which they both go into 12, so I could multiply them so they went to 12. Or I could get the a's to the same number. They both go into 5. So by doing the a's, I would only need to change the top row. With the b's, I would have to change both rows. That's up to you. It's a personal preference. I'm going to go ahead and I'm going to multiply the top row by a -5. Why -5? Because remember, from my last video, I wanted additive inverses. So since this is a -5, I need that to be a +5. So we're going to rewrite those. So we get 5a minus 30b equals -55. I'll make that 0 bigger. And I'm just carrying this one over. Technically, I'm multiplying it by 1. And timesing by 1 or multiplying by 1 keeps something the same. All right, so now it's time for us to actually have this round go on. And when they face off, our elimination or our target that's going to be eliminated this round is going to be the A's. Because 5a and minus 5a, they add to 0, so they go away. -30b plus 4b is -26b. And then -55 and 29 make -26. So this green equation here at the end is beautiful because it allows us to solve for b. It has one variable, we have a coefficient, so we can divide both sides, and we find out that b is going to equal 1. After we find out our first variable, this is when substitution is going to go ahead and become our friend, and we're going to back substitute. So now we're going to come back, and we're going to come back to here. And I'm going to use this equation right here. Why? Because it was close. -5a plus 4b, you'll notice I substituted, equals 29. -5a plus 4 is 29. So now I'll take that 4 away from both sides and divide by -5, which will give me 1a equals -5. Now we have 2 of our answers. So when you're writing your ordered triple, because these are going to be in the 3D world, it's like latitude, longitude, and altitude. The A, we don't, B, and we still need C. Again, alphabetical order is the best way to do these. To get C, we're going to choose any equation that has C in it. We have several to choose from. I'm going to choose the original bottom row, just because it looks nice. So we have A plus 2B plus 3C is going to equal 6. Our A value is -5. 2 times 1, I'll put parentheses around that just to be consistent. And then 3C. If you type this into a calculator, -5 plus 2 times 1, remember order of operations, you multiply, you get 2, and then you add, you get -3. So we'll add that 3 to the other side, divide by 3. And we get C equals 3. So there we have a nice ordered triple. This happens to be a point. Think from your point where you're sitting, you're going to go 5 steps to the left, 1 step forward, and then you're going to hover your hand 3 feet off the ground. That's what this is kind of giving us with an ordered triple. Now, just like with systems of equations in 2 variables, we can have no solution, we can have many solution. So I want to kind of demonstrate what that might mean between the different ones. So we have a plane, which is going to be this table here. We could have a second plane, that piece of paper, and we could have a third plane, another piece of paper. They're all lying on top of each other, so think like they're really embedded in each other. You could have everything be 100% coplanar, and you would have many solutions because they're touching in many spots. Here's another example, is you could have the plane and the calculator piece and the calculator piece. Let's angle that slightly different. Now, the table, the top of the calculator and the calculator itself all meet in a line. Again, it's many solutions. They're just all the solutions following this line. And then like we just found, we could have them meeting at just a point. So yes, the table and the calculator share several points in common, but when you bring in that third piece, it's just a single point. So that's why we can have a point, or we can have many solutions, or they could be like this, where two of the pieces are parallel, and the third one's down there, and they don't all three touch. So therefore, this would be no solution because all three parts don't come together. Or it could be like if you think of a triangle-shaped tent, not all three sides touch in one spot, two sides touch, not all three. And I'm thinking of the triangular part of the tent. So we have a triangle tent. Yes, the left side, the right side, and the front meet at this point. But the left side, the right side, and the bottom don't all three meet at one spot. So that would be an example of no solution as well. So just keep in mind that if you still have variables, you have a solution. It's when all your variables cancel that you're in a no solution or many solution situation. So remember, if all variables cancel, you either get no solutions or many solutions. With the no solutions, you'll see a false statement like 5 equals 12. We know that's not true. With many solutions, you'll get a true statement like 18 equals 18, or 0 equals 0, or something to that effect. So again, I turned my paper sideways just so I would have room to work across the page so that I didn't get confused as I did my bracket work. In our next example, you're going to see x plus y plus z equals 3, x minus y plus z equals 1, and x plus y minus z equals 2. And we could truly target any variable. We could do like we did in our last example and move the bottom row into the middle row and target z's. However, since this is already set up to target y's, I'm going to go ahead and target y first. And the reason why it's set up to target y is when I look at the top two equations, they are additive inverses, positive 1y and negative 1y. When I look at the bottom two equations, they are additive inverses, positive 1y and negative 1y. So we're going to go ahead and we're going to target y. And when I say target y, I mean we're getting rid of y. We're eliminating y. And I left a space in between this time so that we could kind of see a little more of the bracket, maybe that comes together a little bit better for you. So I'm going to cover up that bottom one. Let that, come on, autofocus. There we go. X plus x is going to make 2x. Y plus negative y, that's going to cancel out. 1z plus 1z, that's going to be 2z. And 3 plus 1 is going to be 4. That's great. Our y was eliminated. Repeat. Okay, we've got to finish round one of our tournament here. 1x plus 1x is 2x. Minus y plus y, zeroes out. Plus z and minus z, also zeroes out. And 1 plus 2 is 3. Is that a problem that two variables canceled out? Absolutely not. It actually is your lucky day because we don't have to finish out the tournament. We already know what our variables are going to be. We already know who the quote-unquote winner is. We've isolated x. Because of that, we can take this statement that says 2x equals 3, and we can solve for x by dividing both sides by 2. I like to write things in fraction form. I know a lot of people want to go ahead and use decimals. The problem with decimals is that sometimes you round, and I try not to have rounding error, especially as you move forward into upper level mathematics. And I know a lot of students don't want to have to worry about their significant figures like you do in science class, so fractions are a safe bet, and your calculators are wonderful at handling fractions, so don't be afraid to use fractions. Okay, now I'm going to go ahead, since this has just x and just z in it, I'm going to utilize that to solve for z. So we've got 2 times our x plus 2 times our z, and I write my z's with a line through it so they don't look like 2's. We got 4. If you type this into a calculator, you're going to get 3. Subtract 3 from both sides and divide by 2. And again, I'm going to utilize a fraction. So now I'm just going to come back to the all positive one to solve for x. Sorry, not solve for x, we have x, we need to find y. X plus y plus z equals 3. And 3 halves plus 1 half is 4 halves, or 2. So we really have y plus 2 equals 3. Subtract that 2 over. So even though we organize them and solve for them in a weird order, we are going to put them together as an ordered triple in alphabetical order. So our x is going to come first, our y is going to come second, and our z is going to come third. Fractions are definitely okay answers. What I notice here is that in the bottom row, a has disappeared. It's already eliminated. So I'm not going to worry about that round. It's going to actually help me out. I'm just going to carry that over. And because I'm carrying it over, negative 7b minus 5c equals negative 23. Since this is missing the a, I must target a. And the good news for me is in this example, I wrote it down purposely so that a would already go ahead and be additive inverses so that we could just get to this next step. So when I add these together, negative a and positive a, they target and they cancel out. 3b plus 4b is 7b. Negative 6c and negative c makes negative 7c. Careful with your signs there. 20 and 15 make 35. This is wonderful because what do you notice? I notice that the b's are already additive inverses. One is positive 7, the other is negative 7, which goes, hey, guess what? You're lucky day again. You're ready to target B. So next round of the tournament, quote unquote, we're just going to pop those together. 7b plus negative 7b cancels out. Negative 7c and negative 5c makes negative 12c. And 35 and negative 23 adds to positive 12. So when I divide this out, I get c equals negative 1. I happen to like using a positive coefficient first when I do my substitution back in. So that's why I'm going to go ahead and use this top equation. 7b minus 7 times negative 1 equals 35. 7b plus 7 equals 35. Subtract 7 over and divide by 7. Okay, again, I like using the positive lead coefficient, so I'm going to use this one right here that has a plus 4 times b, which was 4, minus c, which was negative 1. And right here, you're going to see why it's really important that I like to use this parentheses to substitute, because had I not done that, I might not have realized that I had a minus c, which is a minus negative 1, which we see right here. And hopefully you know by now that if you have minus a negative, it's actually a plus. It actually has to do with the fact that there was a coefficient 1 on that c, and negative 1 times negative 1 is positive 1. So if you ever wondered about that, it's actually because two negatives when multiplied together make that positive. The left side is not simplified. I combine 16 and 1 to make 17. Now that the left side is down to 2 terms, I can go ahead and solve for a by subtracting 17 from both sides. And when I take away 17 from both sides, I'm left with a negative 2 on the right. So our ordered triple in this case, A, B, C, alphabetical order. In our next example, you might notice that it's kind of a crazy jumbled mess. We've got variables on the left, we've got variables on the right, they just are not lining up. So we're going to go ahead and take the time to go ahead and line them up first. So 2x plus 3y, I'm going to subtract the z over, and that'll leave me with that constant on the right. I'm going to put the 3x underneath the 2x. I'm going to move the 8z over by subtracting it. I'm going to put it under my other z. And then I'm going to line my 5y and my 7z up below as well. You might look at this and go, well, what do I target? Honestly, it can be very confusing to do what you target on this. Some people are going to choose to target the z's just because it's in every single equation. Some people are going to choose to target the y's because if they just get rid of those y's using the top and bottom, they can move the middle one over. Or some people are going to choose to target the x's. I am going to go ahead in this case and I'm going to target the z's. So I'm going to make the top and bottom one a positive 8z and the middle one a negative 8z. That way I have that negative in the middle for my additive inverses. So to get this to positive 8, I'm going to need to multiply the top row by negative 8. The middle row I'm technically just multiplying by 1, and the bottom row I'm going to multiply by positive 8. And again, I'm going to target z. Why? Because it's in every single one. Negative 16x, negative 24y, plus 8z equals 8. 3x minus 8z equals negative 1. And 40y plus 8z equals negative 8. Now that I've done that step, I can go ahead and I can do my first round. Negative 16x and 3x makes negative 13x. Negative 24y and no y makes negative 24y. 8z and minus 8z cancels out. And then 8 and negative 1 makes positive 7. 3x and no x makes 3x. Nothing and 40y makes 40y. Negative 8z and positive 8z goes away. And negative 1 and negative 8 will make negative 9. Now at this point you might be going, oh my goodness, those are big numbers, 24 and 40. What are they going to get to? Negative 13 and 3, what are they going to get to? Unlike fractions, we're not necessarily always looking for the common denominator, the least common denominator. We just need something in common. However, if you ever do get stuck, just go, all right, this is a 3, so I'm going to multiply the top row by 3. This is a 13, so I'm going to multiply this row by 13. And that'll be a positive 39 in the top, and a negative 39 in the top, and a positive 39 on the bottom, so we're going to be safe there. This is where having full paper comes in handy. And continue to work across. Don't be afraid to use a calculator. Now, cool trick on your calculator is if you don't want to multiply all 3 of them by hand, take the number you're multiplying it by. If you have a graphing calculator, this works on Desmos as well. Negative 13, comma, negative 24, comma, 7. And close that brace. Whoa, I did a parenthesis instead of a comma. Don't do that. And it's going to give you your numbers. Negative 39, negative 72, and positive 21. So I'll do that for my other one. We're doing 13, 3, 40, and negative 9. We get 39, 520, and negative 117. Now, the really cool trick with this comes with the fact that We know we're getting ready to add negative 39 and 39 together, and it's going to make 0. Then we're going to add these together. Okay, fun calculator tricks because sometimes they're handy. So I get enter. Oh, sorry about that, Claire. Plus enter. We can just put in the work. 0, 448, and negative 96. And that would be our x, y, and our answer. So now we have that coefficient of 448. Again, we just added together. Negative 39 and 39 is 0. Negative 72 and 520 is 548. 21 plus negative 117 is negative 96. And when we divide the negative 96, it's going to be divided by the 448. And if you were using decimals, you would be tempted to round this. I know some people think writing all the decimals down is not rounding. The calculator ran out of room. It's better if you go ahead and make it a fraction. That's a pretty simple fraction to write, and it's actually less to write down. So y is going to be negative 3/14. So from there, now we're going to go back substitute, right? When we back substitute, we can choose these with the bigger numbers that are in green, or we can choose one of these with the smaller numbers that are in blue. That's what I'm going to prefer to do, is I'm going to choose that. And again, I generally like doing the positive coefficient, so 3x plus 40 times that negative 3/14 equals negative 9. And we can come in here with our calculator. We get negative 60/7. I love that the TI-84s do an automatic improper fraction. So now we need to add that 60/7 to the other side. So we'll have 9 plus, and it gives us 123/7. Hold on, I have an error. Let's go back and do that again. I forgot a sign. So we have negative 9 plus 60/7. We get negative 3/7. Much better answer. And now we're going to divide both sides by 3. So we're going to take this answer and divide it by 3. That would be negative 1/7. Which makes sense. 3/7 split between 3 people would be 1/7 each, right? Okay, so yes, I understand fractions are not your favorite. However, so we have x and we have y, we just need z. I'm going to choose to just use y to get z, less substitution. So we're going to have 40 times our y value. Actually, I'm going to go back even earlier. I'm going to choose our original blue equation here, right here. 5 times our y value plus z equals negative 1. It's even smaller. There we go. And I could do this in my head. It's negative 15/14. But I know a lot of people want to see that calculator because they trust it and they feel better. Negative 15/14. So we're going to add negative 15, we're going to add 15/14 to the other side, because to get rid of a negative you have to add, right? We'll add 15/14. So negative 1 plus 15/14, we're going to get 1/14. And because I happen to have it written down earlier, because I wanted to make sure with my fractions being not the simplest of fractions that we were correct, by the magic of, me writing this down earlier, we have our ordered triple, our x value, our y value, and our z value. For our next example, we have a smorgasbord of coefficients. So we really can choose which one we want to target. If we're going to target x, 6, 1, and 3 would have a least common multiple, or i.e. if they were denominators, a common denominator, like think over 6, over 1, and over 3, a least common denominator of 6, technically least common multiple. Your coefficients for y, negative 5, 4, and 1 would have a least common multiple of 20. And your least common multiple for your coefficients of z for 3, 6, and 1, again, would be 6. So we just need to choose which one we're going to target. And it honestly does not matter. Once you do, though, you need to make sure that the middle term is the opposite sign of the top and bottom, because we want to utilize that to do the elimination. Just for the fun of it, we have not targeted our first term. So we're going to target x, just to make this different than the other ones. So I'm going to multiply to where everything is 6. So if I multiply this one by 1, it's going to start with a 6x. I'm going to multiply this by 6. That will give me negative 6. But I want this one to be positive 6 again, so I'm going to multiply this row by negative 2. And again, if you want to use a calculator to help you with your multiplying, that's fine. I'm not going to do that this time. And I am going to leave a space. Leave that blank grid. So we'll have negative 6x plus 24y plus 36z equals negative 120. 6x minus 2y minus 2z equals negative 12. And I will tell you, this step is often where most students make their error. They make a small multiplying error, or they forgot to write a sign down. And for my classroom, I have a program that I've written to help me find the small mistakes. Because if you make a mistake in this process, it's probably going to be a tiny one. Most likely a sign error. So just be careful with your adding and your multiplying. So we're going to combine the top and the middle. So 6x and minus 6x, they cancel out. 24y and minus 5y make 19y. 36z and minus 3z is 33z. And negative 120 with positive 6 adds to negative 114. Okay, now the bottom two. 24 and minus 2, we get 22y. I forgot to say the x is canceled out, but I hope you caught on to that. 36 and minus 2 makes 34. Negative 120, adding negative 12 gives me negative 132. And I forgot my z. It's one of those days. All right. Ooh. Not so pretty. Those are some really big numbers. It's okay. We don't need to get scared. We're fine. What do you want to target? I'm going to target y's because they're smaller numbers. So I'm going to multiply this row by 22, and it will be positive in front of the coefficient for y. And I'm going to multiply this one by negative 19 so that I get a negative coefficient for the y. And again, I'm going to use my trick of multiplying because it's fun. So we have 22. It's also less keystrokes on the calculator. Okay. So it gives me 418y plus 726z equals negative 25. 0.08. I like to remember my numbers in twos. I did not enunciate that properly. I understand that. 22, 34, negative 132, negative 418y. Good, because we wanted them to add to 0, right? Negative 646z, and positive 2,508. Okay. So when I add these together and do the next round of the tournament, i.e., right? 418y, negative 418y, when I add those together, they cancel out. 726 minus 646 is 80, so we have 80z. And negative 2,508 plus 2,508 is 0. We still have a variable, so we still have a solution. This is not a no solutions, this is not a many solutions. We have a variable. So we're going to divide both sides by 80. We find out that z equals 0. The altitude is 0. It's just the plane is on the ground, right? There's latitude and longitude, but we're at sea level. So we're going to come back here and we're going to use this one because it's close to find y. Sometimes I don't know why I picked the one that I do. I'm like, this one looks good. As long as you substitute into something and it allows you to solve for one other variable, you're on the right track. Now 34 times 0 is obviously 0. And when we divide this, we'll get y equals negative 6. Mental math wise, I'm not picking the middle equation. Unless you know what 6 times 24 is off the top of your head. I know it, but do you? So I'm going to pick the one with the smallest numbers. The bottom one. I know you guys are awesome at multiplying by 2, so it's a great way to do that. 6x minus 2y minus 2z equals negative 12. So that gives us 6x plus 24. This is minus 0, so I'm not going to write it because minus 0, it's a little extra ink. I have the ink, but why do it? I was getting ahead of myself. That's just 12. 6x plus 12. I was one step ahead. Sorry about that. Now I'm going to subtract 12 to both sides, and that's where that negative 24 is coming in. Sometimes my brain works faster than my hand, or vice versa. Divide by 6. Now we have our latitude, our longitude, and our altitude. So left 4 minus 6, 0. Okay, so here we are. We have to pick a variable to target. It's kind of a flip. The x's would all go into 6. The y's would all go into 60. And the z's would all go into 24. So I'm going to pick the smallest number of that. I'm going to do x's because they all go into 6. So times 3, times 2, times 3, times 6, and I need the middle one to be negative because the other two are positive. 6x minus 8y plus 4z equals 2. Negative 6x minus 9y plus 9z equals 3. 6x plus 60y minus 48z equals 42. Okay, so now we're set up to where we can do our start of our bracket, right? Start of our game. Math Madness? Is that a March Madness? I don't know. All right, so in this first round, the x's are getting eliminated, so 6 plus negative 6 definitely goes away. Negative 8 plus negative 9 is negative 17. 4 plus 9 is positive 13. and 2 plus 3 is 6. 5. I multiplied. That's actually a common thing I see happen with students. All right, so now the bottom. We're again doing that round. X is going to get eliminated, and we see that there. Negative 9 plus 60 is 51. 9 and negative 48 is negative 39. And 3 and 42 is 45. Okay. So we have to target Y or Z, and again, it's a toss-up. So I'll target Z. I'll multiply the top row by 39 and the bottom row by 13, or let's scratch that. If I multiply 13 times 3, it is 39. I don't know if you guys knew that or not. So I'm going to times by 3 and times by 1. That way I have smaller numbers. Negative 17 times 3 is negative 51 plus 39y equals 15 times by 1. And now we can do our math madness. Bracket tournament play, right? Negative 51y and positive 50y cancel out. We are targeting the y. Makes sense. Wow, I didn't catch that. That was supposed to be a z. And that was supposed to be a z. I'll tell you, I'm recording this a little bit later in the day, and I think my brain's kind of fried. So we're going to go ahead and cancel. And these happen to cancel as well. So everything on the left side cancels, and we get 0 equals 60. This is an instance where all of our variables canceled. So, do we have a solution? Well, do we have a true statement? No, this is false. 0 does not equal 60. This is no solution. These three equations will not meet anywhere for all three of them. 2 of them might meet in one spot, but all 3 of them together do not meet. Again, we had a false statement. That's why it's no solution. This is never true. Many solutions just means it's sometimes true, because we didn't say all solutions. Alrighty, this will be the last example for the video. If I'm going to target my x's, 2, 3, and 4, I'll go into 12. Which isn't too bad. Y's, negative 3, 2, and 7, I would have to go to negative 42 or positive 42. And my z's, I'd have to go to 35. So my x's would actually have the smallest least common multiple, so that's what I'm going to go ahead and do. So to get this one to start with a 12, I'm going to multiply everything by 4. 6. I was thinking about the next line. So we get 12x minus 18y plus 30z equals 6. When I multiply this by 4, I need negative 4, negative 12x, and that's so that this will add to 0, minus 8y plus 4z equals negative 16. And to make this 12, I need to multiply by 3. 12x plus 21y minus 21z equals 21. Okay, so now we're going to let those games begin, and we're going to do that math madness. So 12x and negative 12x goes away. Negative 18y plus negative 8y is negative 26y. 30z plus 4z is 34z. 6 plus negative 16 is negative 10. And doing the top two, again, that x, that's our target, so it goes away. Negative 8y plus 21y is 13y. Negative 24 plus 4z is negative 17z. And 21 and negative 16 add together to make a positive 5. So now I get to target the next one. Now some of you might know off the top of your head that 13 times 2 is 26. So I'm going to multiply the bottom row by 2 and keep the top row the same. Negative 26y plus 34z equals negative 10. 26y minus 34z equals positive 10. And now I've got to put them together. Negative 26 plus 26 makes 0. So that's gone. 34 and negative 34 also cancels out. We get 0. Equals negative 10 and 10, 0. 0 equals 0. For the Algebra 2 level, we just write many solutions. Again, this is not all solutions, so this isn't always true. This is just sometimes true. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.